triangle. And then what we did next is we went ahead and constructed a second triangle. So then now it says what will be true, okay, about C and F. You already found that they are in fact the same. And so step 3 was to carefully measure the lengths of the sides of both triangles. Compare the ratios. What do you notice about the ratios?
How do you do that?
The ratios what?
I don't know what to do with the ratios.
Similar?
They're similar. So basically when we talk about a ratio, what that means is that you take the bottom side in each triangle and you write those as a fraction. Okay? Then what you do is you take the left sides of the triangle, you write those as a fraction, and then the right sides, and you write those as a fraction. What do you know about all those fractions?
They're all the same.
They're all the same. Okay? And so what we're going to do is we're going to go ahead and write a conjecture based on that. And so we have an AA similarity conjecture. It says if blank angles of one triangle are congruent to blank angles of another triangle, then what? Okay? So if blank angles, so in this case, if 2 angles of one triangle are congruent to 2 angles of another triangle, why don't we use 3? Because if 2 are the same, the third have to be the same. So it's kind of like saying one of those things. All we have to do is show that 2 angles are the same, and then we can conclude that the triangles are similar. So basically, angle-angle similarity means if you know 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. Now what does that help us do? You're going to see in these next few examples what that helps us do. So we've got an example down below on the next screen, and below the conjecture. And if you notice it says, find side G. So the first thing we need to do is show that these 2 triangles are similar. So let's look. This angle here is congruent to this angle here. All right? This angle here is congruent to this angle here. So these triangles are similar. So that's the biggest thing. You have to show 2 angles are the same, and then you can show they're similar. So basically what that means is that they're in proportion. And so what I usually do for these, if they're similar, is I make a chart. And I call this S and L. What do you think the S stands for? The S stands for small. The L stands for large. And so what I'm going to do, it basically is the small triangle, the large triangle. I'm going to go ahead then now and write each of the sides of the small triangle. Now what I'm going to do is write the corresponding sides. What side matches the 4? 8. What side matches the 7? 14. So now what we need to do is match up side G. What does side G match? 16. So now what I can do is write a proportion then to find what G is. And so what I'm going to do is I'm just going to focus right here. And I'm going to write that as a fraction. So I'm going to write that as 7 over G equals 14 over 16. And some of you might already notice a relationship and already notice that G is going to be 8. Okay, and that's great because if you notice the small is half the size of the large. Otherwise, what you could do now is cross multiply. And so I would cross multiply and take 7 times 16, which comes out to be 112. And then that's going to equal the other side, which is 14G. Okay, if you would divide both sides by 14, you end up getting G to equal 8. So let's go ahead and look at another one. All right, so now this one's a little bit tougher to see because if you notice, you've got the triangles kind of separated. So the biggest thing here is let's compare angles. This angle and this angle are the same, right? This angle and this angle are the same. So these are in fact similar triangles again. But what I need to do now is I need to go ahead and I'm going to go ahead and make my nice little table. And I'm going to do my small and my large. So here's S and here's F. So now this is how we tell what sides they're are in relation to. This side AD is the side between 1 and 2. Now when I say 1 mark, I mean here, and here's the 2 tick marks. So the side between 1 and 2 over here is this one. You see how that works? So then now I'm going to do the same thing for the next triangle. I've got this one here, which is between 1 tick mark and nothing. So here's 1 tick mark and nothing. So I know that the small 12 goes with what? 36. So let's look at the next one. This next one is the only one that's left, and that's the only one I haven't shaded, and that's 42, and that one's M. So in the small triangle it's M, in the big one it's 42. So based on that, I'm going to go ahead and write a proportion. And so my proportion in this case will be 12 over what? I could do 12 over 36, or I could just do this. The reason why I write it this way, okay, is because it's exactly as you, oops, let's try that one again. Slate was acting up. There we go. It's exactly as you see it here. See, this is all I'm doing. Okay. But you could do 12 over 36 equals M over 42 if that would make better sense to you. So you could do 12 over 36 equals M over 42. Okay, so let's go ahead and solve this. So to solve this, I take 12 times 42, which is what? 504. 504. Okay, equals 36 M. All right, let's go ahead and divide. What do you get M to equal? 14. Okay, questions? Okay, let's go and look at another one. Now, as this is written, we have only one angle that is the same, and that's here and here, right? Do you know anything else? Because otherwise, if we can't show that they're similar, we can't find the length of the sides.
Vertical angle.
Ah, vertical angles. So this angle is the same as that angle. So in fact, these are similar. So this is my small, this is my large. Oops, I had trouble with the other. So now what I'm going to go ahead and do is make my chart. So let's just pick a pair. I'm going to start here with the between the 1 and the 2. Okay, between the 1 and the 2 is in the large, it's 100. 1 and the 2 in the small is what?
S.
S right here. Okay, so we'll call that S. All right, let's pick another pair. Let's go with this one right here. So this is between 1 and none. So in the large, that's N. So between 1 and none is right here, which is what? 36. And then, last but not least, let's look at the other one. The other one I have here is between 2 and none. So I end up having 75 and 30. Now this one's a little different because this one, okay, I need to find 2 variables. So what I'm going to start with is I'm going to start with finding N first. And that sounds a little weird, but I'm going to go ahead and find N first. So 30 divided by 36 equals what?
N over 75.
N over 75. I think I said 30 divided by 36. That's wrong. It's 36 divided by 30. And so then now let's cross multiply. What's 36 times 75?
2700.
2700 even?
Yeah.
Okay. Equals 30 times N. So 30 N. Divide both sides by 30, and what do you get N to equal? What'd you say? 90. So there's N. N is 90. Now what I'm going to do is I'm going to go ahead and find S. But what I'm going to do here, it's going to look a little weird. I'm going to go ahead and just cancel out this one right here. And there's my fraction then. So my fraction in this case will be S over 30 equals what? 100 over 75. Now be careful that your S doesn't look like a 5. Okay. So now I have S times 75, which is 75S. And that's going to equal the other side, which is 3,000. Divide both sides by 75, and what do you get S to equal? 40. Questions? biggest thing, make a chart. Okay, that's the biggest piece of advice I can give you. Okay, let's look at this one. So why is triangle TMR similar to triangle THM, which is similar to triangle MHR? So notice we have the similar figure. That's what you learned about, similar. And so we have TMR. So TMR has a right angle here. And THM, which is right here. And MHR, which is right there. Why are they all similar? By angle, similarity. Okay, so now it says find X, Y, and H. So we've actually got 3 triangles, right? Okay, so the first triangle I'm going to start with is the big one, TMR. Okay, so here's TMR. I know that TMR sides are 32, 60, and 68. And then I have another triangle, THM. And THM size, what is THM? What is the same as 60 in THM? THM is right here.
What's the question?
What is the same?
TM is 60.
TM is 60 right
Oh,
here. Okay, so that's the hypotenuse, so that's going to be the same as 68. Okay. What is this side going to be the same as?
Oh, I thought. I don't.
This is what you might want to do here. If you are doing this and you're struggling, let's draw them out this way. So here we go. 60, 68, 32. Then let's go ahead and write that one out. Oops, let's try that one again. That was a bad line. Now this one is actually THM. So here's H, here's T, and here's M. So HM we know is H. We know that TH is Y. And what's TM? 60. So let's see, what is the same as TM? We already did that with 60. What's the same as H? 32. What's the same as 60? Y. So then we now have HRM. Okay. All right, so HRM, here we go. So this is 32, right? And here's H and R. And R is X. So what does 32 correspond to? The 60 and the 68. What does the X correspond to? The H and the 32, very good. And then we know that H corresponds to the HRM. So let's go ahead and write some proportions here. I'm going to start with this one right here. Okay? So I'm going to start with that one. So in order to do that one, first of all, I'm going to go ahead and erase some of these so that I have some room. So we already know that we have 60 over 68 equals y over 60. So cross multiply, you get 3,600 equals 68y. What does y equal? 52.9. Good. Okay, so now we have to write another proportion. So what I'm going to do is I'm going to do this one. Right? So 32 over 68 equals what? H over 60. So did you already solve this one? So you said 1920 equals 68H, 28.2 for H. And then last but not least, I have to do an x and a 36, or x and a 32, sorry. So I'm going to go ahead and do 32 over 68 equals x over 32. So I end up getting 68x to equal what? What's 32 times 32? 1024. What does x equal? 15.1. There you go. Questions? All right, these are going to be tough. I'm going to warn you. Okay? And so if you look at this one, look at what it says. TA is parallel to UR. Now notice these are 8 and 9 on your homework, if you're paying attention. Okay, is QTA congruent to TUR? So is this angle here congruent to this angle here, yes or no?
Yes.
Why?
I don't know. Something very
Conjecture. What type of angles are they?
What,
Corresponding?
Corresponding angles. Good. So those are corresponding angles. So let's look at the next one. Is QAT, quad, congruent to ARU? Is that true?
Yes.
Why? Corresponding angles. So now it says, why is QTA congruent to QUR? Angle similarity. Good. So now what we need to do is we need to find E. So the biggest thing that I can do that would help you out is to draw it out. So here's QTA. Okay, I know QT is 3, QA is 4. Then you have a bigger one here, which is QUR. What is the length of QU? Yep, which is what? 8. And then this one is E plus 4. Okay, because notice here you have 4 and you have E, so you add them together. So my proportion will be 3 over 8 equals what over what? 4 over E plus 4. So now I need to cross multiply. Now when I cross multiply, I end up having 3 times E plus 4. And what will that equal? Well, it's going to equal 32, right? And then I'm going to go ahead and distribute. So it does equal 3E plus 12 equals 32. So if you subtract 12, what do you get 3E to equal? 20. So E equals approximately 20 over 3, or 6 2/3. Okay. Questions? Any questions? There is another way you could have done that. You could have done 3 over 5 equals what? 4 over E. And that would have given you the same answer. Either of them work. Okay. So what you need to do for me for Thursday, this is due Thursday since I'm gone tomorrow, I need you to do 1 through 10 on page 592. Now notice I just did 2 of them for you. Okay, we've got a worksheet and probably a short quiz tomorrow. Okay, come ready to go Thursday.